All right, welcome people. Welcome to today's lesson. So yesterday we were talking about solving these by factoring, and our goal was to get to a point where we were able to have something times something else equals 0, set both of those parentheses equal to 0, and then continue solving for x. So we set this parentheses equal to 0 and this parentheses equal to 0 and solve for x. However, we're going to run into some situations like this, where we don't necessarily have two things that end up multiplying to be the third thing, or that end up adding to be the both multiplying to be the third thing and adding to be the middle thing. So we don't have anything that multiplies to be negative 10 that adds to be negative 6. Okay? So that's where we're going to start today. So the factoring method works really well when you have nice rational number answers. But sometimes you're going to get irrational number or even imaginary number answers. So that would be a situation like this, where you're not going to get nice rational number answers. So before we move on, there are some steps that you want to run through when you are trying to solve a quadratic equation. So things you want to check for when you are trying to solve a quadratic equation. First, you want to check to see if you can get it to be something like x squared just equals some number. If you can get it to be x squared equals some number, that's great. That's the first thing that we looked at. Go there and solve that. Then, if you can't do this, can you factor the expression? If you can, go for it. That's going to be your next easiest course of action. Third, we want to check to see if we can complete the square. We haven't talked about what completing the square is, but luckily, as you hopefully have noticed along the left side of the screen, that's what we're talking about today. If you can complete the square, great. If not, then you want to use the quadratic formula. Okay, so let's take a look at a couple problems. So here we have x squared plus 7x plus 6 equals 0. We're going to solve this a couple different ways. First, if we want to try to factor this, we need two numbers that multiply to be 6 that add to be 7. Those are 6 and 1. So we have x plus 6 times x plus 1 equals 0. And then we have two numbers that are multiplying to be 0, so we have to check to see if either of them can be 0. X plus 6, can that be 0? X plus 1, can that be 0? Solve both of these, we get x equals negative 6 and x equals negative 1. So the other way that I wanted to try and take a look at this is a process called completing the square. Completing the square. Okay. This process you can use on any quadratic equation ever, even if it doesn't have nice factors like these guys or nice rational number factors like this guy. You can use this on any quadratic equation ever. However, I would always recommend try to use this when a equals 1. So the number in front of x squared, so this guy right here. If we can get a to be equal to 1 and have nice numbers to work with, completing the square is going to be your friend. So how do we start completing the square? So the first step in completing the square is to get the problem to look like this. We want to have just x squared plus some number times x equals some number. Okay? So if we have something that looks like we have right now with the x squared plus 7x plus 6 equals 0, we want to get all the number terms over onto the other side. So let's go ahead. We'll start with x squared plus 7x, x squared plus 7x plus 6 equals 0, and we want to get it to be x squared plus bx equals c. So let's move this guy over to the other side. X squared plus 7x equals negative 6. Okay, so this is where the completing the square magic comes in. We are going to take a look at this middle term right here, and we're going to say, all right, we're going to call that letter b. We're then going to take that number and divide it by 2, and we are going to square that. b over 2 squared. All right, so once we do that, this is going to become 7 over 2, and we are going to square that, which ends up being 49 over 4. We are going to take this guy that that we just found. This is our completing the square term, and we are going to use that to complete this square, to complete the square over on the left side. So we get x squared plus 7x, and this is where, back when we were talking about factoring, all those rules came in. So we have plus 49 over 4. We're going to add that number to one side of our equation. If we add it to one side, then we're going to have to add it to the other side. Negative 6 plus 49 over 4. So then from here, we now have a perfect square trinomial over on this side. And if you remember back from when we were talking about factoring, this is one of those nice scenarios where we have a perfect square on the left, a perfect square on the right, and then 2 times the square roots of each of those in the middle. So this is going to factor down to x plus 7 over 2 squared. That factors down to x plus 7 over 2 squared, which equals, if we write negative 6 as a number of fourths, we're going to get negative 24 over 4 plus 49 over 4. So negative 24 plus 49 over 4 gives us 25 over 4. And then that equals x plus 7 over 2 squared. Okay, going to extend the page a little bit, if I can ever actually poke the extend page button. There we go. So here we are with this squared term equaling some number. To undo this square, we square root both sides. X plus 7 over 2 is the square root of that thing squared, equals plus or minus the square root of 25 over 4. So the square root of 25 over 4, well, the square root of 25 is 5, the square root of 4 is 2. That's going to be plus or minus 5 over 2. Okay, so then we have x plus 7 over 2 equals plus or minus 5 over 2. So we're going to move our 7 over 2 over. And we're going to have x equals 7 over 2 plus or minus 5 over 2. Whoopsie daisies. Had to subtract that 7 over 2. So negative 7 over 2 plus or minus 5 over 2. So once we're here, we then say, okay, I have negative 7 halves. If I add 5 halves to them, so we're going to do the top part of this first. So we have x, this is going to split into 2 things. X equals negative 7 over 2 plus 5 over 2, or x equals negative 7 over 2 minus 5 over 2. So once we're here, x, negative 7 over 2 plus 5 over 2 is equal to negative 2 over 2, which is the same thing as negative 1. So x equals negative 1, and x equals negative 12 over 2, which is negative 6. If you take a look, negative 1, negative 6, negative 1, negative 6. Okay, 2 paths to the same place. Only difference is completing the square works every single time. Every single time. So, it's up to you which of these you decide to use. If you recognize you can factor, you'll see that you have to do a lot less stuff. All right, factoring is going to be easiest. That's why I said to look for that first. With completing the square, it always works. It always works, but sometimes you might have to do a little more work to get there. Okay? So let's take another look at another problem. Here we have 3x squared plus 5x minus 2. I want you to take a look. I want you to take a second and pause the video, and I want you to decide: can I get x squared equals some number? Can I factor this thing? Or can I use completing the square? Which of these should I use? All right, so I'm going to pause. I'm going to give you a second to pause the video and think about that. Okay, hopefully you're back. So hopefully you recognize I might be able to factor this. Always try that first. All right, so if we factor this, we need 2 numbers that multiply to be negative 6 that add to be positive 5. Well, in that case, we would just use positive 6 and negative 1. All right, so if we take 3x squared plus 6x minus 2 equals 0, we can factor this and get 3x times x plus 2. And these the second group of 2 has a negative 1 in common, so we factor that one out. Negative 1 times x plus 2. These two parentheses are identical, so we can use that. Factor out x plus 2, and then group that with 3x minus 1 is what's left over after we factor out that x plus 2. Equals 0. We have something times something else equals 0. Therefore, one of those two things has to be 0. We don't know which one because they both have variables, so we have to check to see what would make either of them 0. X plus 2 equals 0, or 3x minus 1 equals 0. Solve for x, we get x equals 2, negative 2, or x equals 1/3. Okay? So those are our two solutions for this particular guy. Okay? You could have used completing the square. However, this guy right here, the fact that this is a 3, means that using the completing the square thing is going to be gross because we have to get that thing to be 1. The only way we can do that is by dividing all those terms by 3. Once we divide all those terms by 3, we're going to get some really, really gross stuff. So I wouldn't recommend using completing the square with anything that's not 1. Okay? Let's take a look at this. Factoring, completing the square, what are we going to use? Pick a strategy, try solving it, and I'll be back. Welcome back. Hopefully you decided that completing the square was the path to take for this. If you tried to factor it, you would be sorely disappointed that you can't find two numbers that multiply to be negative 22 that add to be negative 10. But completing the square would go as follows. Remember, we want to get these guys into some form where it is x squared plus or minus some number of x's equaling some other number. Okay? Once we have that, then we go ahead and we say, all right, what is the number that is attached to just the x? Take that number divided by 2, so b over 2, and square it. So 10 divided by 2 squared, so 10 over 2 is 5 squared, which is going to be 25. So we take that 25 and we add it to both sides of our equation, so our equation stays balanced. 25 on the left, 25 on the right. Factoring this left side now gives us x minus 5 squared, because this is a minus sign right here. And 22 plus 25 is 47. 22 plus 25 is 47. All right. Then, if we take to undo this square, we want to square root both sides. So we get positive or negative the square root of 47 on the right side, and then just x minus 5 on the left. Then we move remove 5 over by adding 5 to both sides. So we get x equals 5 plus or minus the square root of 47. Those are both of our solutions. You don't need to give me some weird decimal approximation of that number. Okay? Please just leave it as 5 plus or minus the square root of 47. Okay? So here's one more. Give this a shot. Pause this one on your own. I'm going to tell you right now, completing the square is the way to go for this one. All right? Pause it. Try to work through completing the square, and I will see you on the other side with the solution. All right, we are back. Hopefully, this is what you did for your completing the square process. First, we have to get it to something like this setup, where we have x squared plus some number of x's equals some other number. Okay, x squared plus some number of x's equals some other number. Then we take whatever that number of x's is, divide that by 2, and square it. All right, so 6 over 2 is 3. 3 squared is going to be 9. We then take that 9, add it to both sides of our equation. Again, keeping our equation balanced, we are allowed to add the same thing to both sides of an equation. Then we have a perfect square trinomial here, where we have x plus 3 squared, this guy. And then negative 13 plus 9 is going to be negative 4. To undo this square, we take the square root of both sides. The square root of negative 4 is plus or minus the square root of negative 4, which is plus or minus the square root of 4 is 2. Square root of negative 1 is I. So plus or minus 2i is going to be over on this side. So we have x plus 3 equals plus or minus 2i. We're going to move the 3 over by subtracting, and we get x equals negative 3 plus or minus 2i. And this is both of our solutions. Both of our solutions. Both of them are imaginary, but they are both still solutions. Okay? So that that about covers it for completing the square. But if you use completing the square on our standard form equation, if you use that completing the square idea on our standard form equation, you get this guy. This is our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, this is a thing that I want you to know. This is why I want you to have burned into your brain. Okay, this is a thing I want you to have burned into your brain. So we are going to use this idea to solve equations. Essentially, if those first three methods fail, the getting x squared to equal some number, so you can just take the square root of both sides. If factoring fails, and if a is not 1, if a is not 1, things can get pretty gross with completing the square. So I would recommend using this quadratic formula in place of completing the square. All right, so let's take a look at a couple problems. All right, so let's take a look at this guy. We have x squared plus 6x plus 8 equals 0. Hopefully, if you're going through your checklist, you'll see, okay, I can't get x squared to equal some number, but I can factor this. This is actually x plus 2 times x plus 4 equals 0. X plus 2 equals 0. X plus 4 equals 0. And then x equals negative 2. X equals negative 4. Okay? These are our two solutions. These are the two that we are going to be able to use. So factoring is our friend here. All right, but in case you didn't recognize that you could factor, and you didn't want to use completing the square, you could use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, that whole thing over 2a. All right, so let's fill in our variables. Let's fill in our a's, b's, and c's. X equals negative 6 plus or minus the square root of 6 squared minus 4 times a, in this case, is 1. C, in this case, is 8. All over 2 times 1. All right, so let's simplify a little bit. We get that x equals negative 6 plus or minus the square root of 6 squared is 36 minus 4 times 1 times 8. 4 times 8 is 32. All over 2 times 1 is 2. Let's keep going, simplifying. Negative 6 plus or minus the square root of 36 minus 32 is 4 over 2. Keep simplifying. Square root of 4 is 2, so we have x equals negative 6 plus or minus 2 over 2. All right. So then once we get here, there's no more simplification to do. We just have essentially two separate problems. We have negative 6 plus 2 over 2, and we have negative 6 minus 2 over 2. So this guy right here is going to be negative 4 over 2, which is going to be negative 2. And this guy is going to be negative 8 over 2, which is going to be negative 4. So we have negative 2 and negative 4, just like we did over here. Okay? Also, I didn't mean for it to, but this right here looks like a face. Try to unsee the face. It doesn't work. It's stuck there. Okay? But solving using factoring and solving using the quadratic formula both get you to the same spot. Again, if you can recognize factoring, I would say that this is a little bit less work than this. Okay? Save yourself some time. Learn to recognize when you're able to factor. Okay? Let's take a look at another one. Something like this. Okay? Take a second, figure out what method you're going to use to solve this, and we will go from there. Take a second. How would you solve this? Solve it, and then I'll be back. All right, welcome back. There's a number of different ways you could go with this. All right, any of the four methods, well, 3 of the 4, we can't get x squared equals some number. So any of those second group of 3 methods will work for this. All right, I chose to factor. All right, look for the thing they have in common. Both of these terms have a 9x in common. If we factor out that 9x, we get that 9x times x plus 2 equals 0. So we have 9x times this equals 0. Something times something else equals 0. The only way that's true is if either one of those two things are 0, is if one of those two things are 0. So I set 9x equal to 0. Could have just set x equal to 0, but I just took the whole 9x and then divided both sides by 9. 0 divided by 9 is still going to be 0. So x equals 0. Over here, x plus 2 equals 0, or x equals negative 2. Again, however you decided to solve that is up to you. Feel free to solve this by any means that you determine is necessary. Okay? Let's take a look at this. All right, 3x squared plus 2x equals 7. All right, again, determine whether you can factor, determine whether you can, determine whether you can get x squared equals some number, then determine whether you can factor, determine whether completing the square is going to be a good choice, and then finally, determine whether or not you want to use the quadratic formula. All right, go ahead and work through that, and I will be right back. All right, hopefully you found your way to the finish line. In my opinion, I think that solving this guy using the quadratic formula is probably going to be easiest. Okay. Again, in order to use the quadratic formula, you need to make sure that everything is over on to the left side. So we want to make sure that we move this 7 over on the left side and have 0 over on the right. So when we use our quadratic formula, again, negative b plus or minus the square root of b squared minus 4ac all over 2a. And then from there we plug stuff in like I did here, and then simplify again like I did here. So multiplying this guy together got me 84. 2 times 3 is 6. And then 4 plus 84 is 88. So then we have negative 2 plus or minus the square root of 88 over 6. Whenever you have large things under the square root, it's generally a good idea to see if you can simplify that square root any. So I did. I made a factor tree and found that I had a group of 2's that was able to come out. So I factored that out front. And then 2 over 6 and 2 over 6 both reduced to 1/3. So I just factored a 2 out of the top, a 2 out of the bottom, and we're left with negative 1 plus or minus the square root of 22 over 3. Okay, so that's what you should have gotten for this guy. All right, again, the most important thing is that you're making a decision as far as how you want to try to solve these, and then following through on that decision. And then if that doesn't work, I need you then to back up and try something else. Okay? So, the next thing that we're going to talk about is called the discriminant. Okay? The discriminant is a number that tells you how many real number solutions exist for a given quadratic equation. Okay? It tells you how many real number solutions exist for a given quadratic equation. And it's this b minus 4ac. If you go back to the quadratic formula, it's this part right underneath the square root. This guy, b squared minus 4ac. Okay? This is what's called the discriminant. And that tells you how many real number solutions there are for a quadratic. All right? So, if you calculate that and you get a number that is larger than 0, okay, you calculate that number and you get a number that is larger than 0, you have 2 real number solutions. You have 2 real number solutions. If you calculate that value and it ends up being exactly 0, you get 1 real number solution. Okay, you get 1 real number solution. If you calculate that value and you get a number that is larger than 0, you get 0 real number solutions. You'll get 2 imaginary solutions with this. Okay? So this is your table. Go ahead and take a second to copy that down. Feel free to pause the video, but I'm just going to keep going. Okay? So, let's take a look at this. How many real number solutions does this guy have? Well, again, we need to move everything over so that way we can use our quadratic formula. So 3x squared plus 2x minus 7 equals 0. So we're looking for b squared minus 4ac. Well, in this case, b is 2, so 2 squared minus 4 times 3 times negative 7. Okay? So 2 squared minus negative 84. 2 squared is 4. 2 squared is 4. So 4 plus 84 is going to be 88. Since 88 is a positive number, we can say that we're going to have 2 real solutions because we calculated out that discriminant. Okay? So take a look at this one. Give this one a shot on your own. How many real number solutions are you going to get? I don't need to know what those are. In fact, you've already calculated them. But how many real number solutions do you get for this guy? Give the video a pause, and I'll be back in a minute. All right, welcome back. So by using discriminant, if we take b squared, so 6 squared is going to be 36, minus 4 times a times c, 4 times 1 times 13. 4 times 13 is going to be 52, so 36 minus 52 is going to be negative 16. Because our discriminant is negative 16, we can say, therefore, we have, there exist no real solutions. And if you want to flip back to when you solved this one, you found that both of those solutions were imaginary. Both those solutions are imaginary. Okay? So that's how this works. That's how the discriminant works. You're taking and looking at that quadratic and just being able to say, okay, I can expect this many solutions. Okay? Here's one more for practice. If you want to give it a shot, spoiler alert, there are not going to be any real number solutions. Okay? So from here, I will have an assignment for you. So I'm going to ask that you continue to work on that assignment till the end of class, and it will be due at the beginning of class tomorrow. All right. If you have any questions, I should be in the building later today, so feel free to come find me, and I'd be happy to help you think through any of these problems. All right. Have a great one, and I will see you guys tomorrow, if not sooner. Okay. Bye.